We're going to break this lesson into 2 videos just because it can be a bit much. We are going to be talking about basically distance problems. We call them motion problems. And what I like to do first off is give my kids all these scenarios. So of all object motion problems that you do, most of them can be broken into 5 categories. So the first one is just plug and chug. That's when I give you, here's a distance, here's a rate, find the time. So you're just going to use this formula, which hopefully is familiar. So we're going to just make a little cheat here that we use d equals rate times time. And like I said, I'll give you 2 of them. You just find out the other one. Then we have head start problems, and that's where something or someone leaves before the other. So they're going to the same destination. It's just someone gets ahead somehow. So when we have head starts, we're actually going to do distance 1 equals distance 2. So most of these questions will have 2 objects in them, so you have to create labels. So the first object's distance we'll call D1, and the second object's distance we'll call distance 2. Work together problems, that's when 2 things start apart and they come together, or they start at the same spot but they go in opposite directions. So when we see that, we actually want to add our distances together, and I will provide you with a total distance. So distance 1 plus distance 2 equals total distance. And then you have fall behind. So fall behind is kind of like when you race someone, so you'll both leave at the same spot at the same time, but someone's going to go faster. The other person's going to literally fall behind. So for fall behinds, we want to do D1 minus D2, and that will equal a certain distance apart. So I'll say how long until they're 50 meters apart or something like that. And then compare to find, it's basically another type of problem that doesn't fit in any of these. You still have 2 formulas and then you do something. So it's actually going to be the same setup as a head start problem, but it won't be worded like a head start problem. So we'll just kind of worry about that when we come to an example. All right, so we're going to do an example of plug and chug. So you want to start with distance equals rate times time. And it says a car is traveling this fast. So here's your rate. Oops, I meant to write right here. So we're going to put 50 in for R. And it's traveling for 3 hours. Okay, so that's the time. Find the distance. So looks like 150 miles. Pretty simple. Example 2, this time I'm going to give you a distance of 220 miles. And we're going to cover that in 4 hours. So that's your time. So now my formula would look like 220 equals rate times 4. So we're going to divide by 4 on both sides. And we're going to get R equals 55. And since you're finding speed, it looks like it's miles per hour. So those are probably the easiest problems that you'll ever get. The next problem says, Jose left the airport and traveled toward the mountains. Kayla left after him about 2.1 hours later, but she was traveling faster in order to catch up to him. So obviously it's a head start because Jose left sooner, but they're going to the same destination. After 1.2 hours, she finally catches up, find his speed. So the first thing I like to do is I like to draw myself a table because I'm going to have 2 rates, 1 for each person, and 2 times 1 for each person. So it looks like we don't know Jose's speed. We'll have to leave that as R. So R can stand for Jose's speed. When we talk about Kayla's speed, it just says she was going 35 faster than him. So what you have to do is take his speed and you have to add 35. So R plus 35 will represent Kayla's speed. And then it says Jose left the airport, traveled toward the mountains. Kayla left 2.1 hours later, blah, 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 blah. Kayla has basically driven for 1.2 hours. So she leaves, and after 1.2 hours of driving, she catches up. So she has been on the road for 1.2 hours. Jose, however, you have to remember, he had a 2.1 hour head start. So he's actually been driving for 2.1 hours, plus it took her 1.2 hours. Well, he's driving while she's driving, so we have to combine those numbers to make 3.3 hours. So he has been driving 3.3 hours. So our setup for head starts is we want our distances to be equal. So if I want Jose's distance, I have to do his rate times his time. So that's 3.3 R. And for Kayla's distance, I have to do her rate, which is R plus 35, times her time, which is 1.2. And then once you do that, you just go through and you solve it. So as you solve, you should get 20 miles per hour. And the last thing I do is just make sure I actually answer the question, because I could technically ask for either of these numbers. It says find Jose's speed. So if I put 20 in for R, I've got Jose's. So I know I'm done. If it asks for Kayla's speed, however, you'd have to do 20 plus 35. That's 55 because she's driving faster. Okay, so this one will be our last problem we do together. It's called a work together. You have two bicyclists. They're going to travel in opposite directions on a circular bike trail. So here's one bicyclist, going to kind of drive like that. The other bicyclist is going to start at the same time and point, but they're going to go this way. And they're telling you that whole trail is 5 miles long. So it says the first cyclist is going 12 miles per hour. The second one is traveling 18. So here's what's happening. The bicyclist who's going faster, okay, is going to cover more ground. The person who's only going 12, they're still going to be biking the same amount of hours, but they're not going to be going as far. And that's okay. But they both left at the same time. That means they're riding their bikes for the same amount of hours. So you put T in here for both. So the key word here is noticing they're in opposite directions. Anytime someone's going in opposites, you add. So we're going to do D1 plus D2, and the trail is a total of 5 miles long. So bike 1's distance is 12T. Bike 2's distance is 18T. And we just solved that equation really quick. So you can say T is equal to 1/6 hours, or if you take that times 60 minutes for every hour, you're going to get 10 minutes. My guess is 10 minutes is probably a more common answer. You don't tell your friends, I'll be there in a 1/6 of an hour. You'd say 10 minutes.